Scientific notation. So scientific notation is something that we use in chemistry and other sciences as well when we're trying to work with really big or really small numbers. You can see these two examples right here. It's just partly annoying to write all those zeros, and it takes a long time to really understand how big that number is. So we start writing it in scientific notation. So if you look at our two scientific notation examples, they both have a similar format. All right, you have what's called a base number. That's the first number you're going to write. And you'll notice both of those have the decimal point after the first digit. All right, so it's always going to be 1 point something, 2 point something, 3 point something, 4 point something, and so on. You will not, in chemistry, we do not want you to write 10 point something. It would be 1 point something. Okay, and then they also all have the times 10, and then this is the other number you need to figure out. That's going to be the exponent. Okay, a couple things looking at these exponents. Right away, you see we've got times 10 to the 23rd, and that corresponds with this number. So when that exponent is a positive value, it's going to be really big. So if you actually were to put in 10 raised to the 23rd power into your calculator, it might not even show you all the zeros because that's a really big number, and we're taking 6.02 times that number. And then the second one, the 7.2, you notice there's a negative exponent. So that means we're working with a really small number. So if, for example, just go with something a little bit simpler. If we were working with something that was times 10 to the negative 2, if I put that in my calculator, that is equivalent to 0.01. All right, so what I'm doing is I'm taking a number, multiplying it by 0.01 to make it a smaller number. So let's say it was 2.5 times 10 negative second. What that means is I'm taking 2.5 and I'm multiplying it by 0.01. And if I actually put that into the calculator, sorry, this should be 2.5. 2.5 times 0.01. My answer is going to be 0.025. So when we're doing this times 10 to the negative 2, what we're actually doing is we're multiplying that base number by an actual number, but we do everything as the times 10 to be able to compare things. All right, so let's take a look at some examples. All right, we want you to write the following numbers in scientific notation. Again, when you're writing it in scientific notation, it is going to be a number, decimal point, some other numbers, and then times, I probably shouldn't have used x's for that, but anyway, times 10, and you need to figure out the exponent. All right, if it is a positive exponent, it is going to be a large value. If it's a negative exponent, it is going to be a small value. Okay, so we start with the base number. So with this one, I have my everything but the zeros. So I'm going to do 3.240. I am going to keep that 0 on the end, and that has to do with significant figures. All right, then I've got times 10. Now I need to figure out, well, what is my exponent going to be? I already know it's going to be negative something because I'm working with a small number. So I start with where the decimal point currently is, and I need to see how many places I need to move it to get it between the 3 and the 2, which is where I put it in my base number. So 1, 2, 3, 4. So this is times 10 to the negative 4. Because again, I wanted to figure out what that number is. I look at where the decimal point is currently in my number and then where I want to move it to. And that tells me how many places I have to move it over. So let's try the second one. 6, we've got 6 million kilograms. So I'm going to do, because of significant figures, I'm just going to do 6 times 10. And now I need to figure out what the exponent is. All right. So in this one, it's a little bit more tricky because there's really, that decimal point is not written anywhere. You just have to assume where it is. And so if you don't see a decimal point, you can assume it's at the end of the number. So I'm moving it to after the 6. So I need to figure out how many places I moved it over. So 1, 2, 3, 4, 5, 6. So this would be 6 times 10 to the 6th. All right, and then we'll try the bottom two. So the bottom two are going the other direction. So we're going to give you the number in scientific notation, and we want you to convert it into standard notation. All right, so a couple things. One, this -4 means that it's going to, some number is going to start with a 0. This is going to be 0 point something because it's a negative value. So what I like to do, and I'm actually just going to rewrite this down here so I don't run into that little letter A there. I need to see, it tells me I need to move it over 4 places. And since I know it's -4, I need to move it over to the left because, again, I need to start with 0 point something because -4 means it's a real small number. So I move it over 1 to get it in front of the 8, a second one, third one, fourth one, and that's where my decimal point is going to end. So I look at this and I've got 1, 2, 3. So after my decimal point, 1, 2, 3, and then I am back to the 8, 7, 4. All right, and then the bottom one, 10 to the third. So it's getting larger. So I start, and again, I'm going to rewrite my 9.26. I have a little bit more room to work with. And I'm going to move it over to the right 3 places. So 1, 2, 3. And so I need to put a 0 in the end there to make the number 9,260. And I should be following what we ask you to do and leave the units on these because, again, they are measurements, not just random numbers. I do want to talk about this one at the bottom again, just to kind of hit home this point of what this 10 to the third means. So if you put 10 raised to the third power in your calculator, 10 to the third is 1,000. All right, so again, I just plug it in, and that's what it means. Because remember, 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. So what I'm doing is I'm taking 9.26 times 1,000 is really what that means. So it's another way to look at how we got the 9,260. All right, and that is scientific notation.